So first of all, what is location intelligence? So we think most organizations are really missing an opportunity. We think only about 80% of the data, about 80% of data that's collected has a location component, but businesses are only really using about 10% of that to power business decisions, which means there's a huge opportunity for companies to exploit that. So why should people care about where? Why is that something that should be mattering to your business? So first of all, and I think most importantly, without where, you often can't understand why. If you're asking questions about why things are happening in your business, so often where can be the driving factor or one of the driving factors behind that. And if you're not thinking about it, then you're not going to get the answer. Secondly, it offers much more insight and nuance and intelligence behind decision making, which can really help de-risk your decision making. Thirdly, post-pandemic, the rules of geography are constantly changing, and everything that we learn in sort of our GCSE geography lessons has really changed, and it's continuing to change. And we can't any longer say, "Oh, I just know where that happens," or "I just know why that happens where." Something we often face with our clients when we're talking with them about what they can use Carto for is say, "Oh, well, I just know that high street would be great for my store. I just know it should go there. It would be a success." But actually, because things have changed so much recently, that's not necessarily a given. Fourthly, location is something that we all understand and experience. So people really love maps, and they're something that's really emotive and really engaging. So if you want people to care about what you're doing, maps can be an amazing tool for doing that. And finally, they're a really concise tool. So you can communicate in one map what would take you 1,000 words or 10 bar charts to do. So that's why we think where matters. So I'm just going to briefly go into a case study of if you were going to do some analysis with or without location intelligence. So say the problem is I work for a car share club in Europe and I want to expand to London potentially. So I'm trying to find out if that's a good idea for my business. So my approach to that is I want to investigate levels of car ownership in London. So without location intelligence, I might make a bar chart and I might look at the percentage of households that do and don't own a car. So we can see from this that while fewer households don't own a car, that's still over 1 million households. So it's a good sized market. So yeah, we should expand to here. But with location intelligence, we can see that the picture is much more complicated than that. So the blue areas on this map are where more households don't own a car. The pink areas are where households don't own a car, and the blue areas are where more households do own a car. And you can see that there's a really strong pattern here. Much more people in the centre of London don't own a car, and it's a really it's sort of a tale of two cities in a way. So with location intelligence, we actually have quite a different outcome to without location intelligence. So we can still say, yes, we should expand to London, but actually our market is much larger and denser in the centre and inner city. So for our greatest return on investment, we should just expand to these areas rather than the whole city. Otherwise, we're going to have really low uptake in the suburbs and we won't get a good return on investment. So what does Carto do to help businesses take advantage of these things? So we sort of frame it in this way. If you're trying to understand where something is happening, maybe where are tourists staying and where are they going to and where are they coming from, then you might be using a business intelligence platform, something like Power BI or Tableau. But if you want to really delve into the why and the data science behind that, for location intelligence, you really need a location intelligence platform. And the example question there would be, can we model the patterns and movements of tourists to improve operational efficiency? So it's really delving into that why rather than just the plotting where. So sort of before Carto, BC, data couldn't be accessed on the cloud, particularly geospatial data. So organizations needed to access this data via specialized platforms and databases, which they had to have on their desktop. And this meant it was really isolated to just specialists who had a GIS background, maybe a GIS degree or master's degree. But with Carto, we want to do something different. We're a cloud-native location intelligence platform as the sort of first USP for us, which means you can plug in directly to all of your cloud data warehouses, your Snowflakes, your BigQueries, your Databricks, directly from Carto and perform all your analysis really seamlessly. But our mission is really to empower our users with the best data and tools to really unlock the power of geospatial. Our real mission is we want to democratize access to location intelligence. So it's not just for the specialists, it's for everyone. So how does Carto add value? What does it actually look like? There's sort of 5 main areas that I see that we add value for people. First of all, connectivity. So as I mentioned, we're cloud native, so you can access all of this stuff directly from the cloud. premium data, and I'm going to show you Wi-Fi pending this a little bit later. We've got a data observatory that has over 11,000 premium data sets on it. That includes things like footfall, spend data, demographic data, environmental data. There's so much on there. If you Google Carto Spatial Data Catalog, there's a public-facing version. You'll be able to explore all of this. And when I first came across it, I was really floored. There's so much on there. Thirdly, build, visualize, and share your data so you can perform browser-based analysis rather than having to perform your analysis on a desktop software package, then upload onto your browser to make web maps. You can do all that on the browser with Carto, and you don't need any GIS experience to be able to do that. There's point-and-click tools, and there's also a SQL console. So if you are a SQL user, you can do that. Fourthly, solving problems. So we have an analytics toolbox, which is a suite of bespoke functions that people can use to analyze their data. And we also have Carto Frames, which is a Python package where you can plug directly into your Jupyter notebook. And then finally, an end-to-end offering. So our customers get access to our whole tech stack, APIs, connectors, libraries, Python, SDKs. There's so much in there. So I mentioned our analytics toolbox, and these are just some of the tools that we offer people, and I'll give you some examples in a second. You can enrich your data with our data observatory datasets. So I mentioned that we have over 11,000 datasets, and you can plug that into your data, whether that's a study area, operational area, and work out what those datasets look like in your area. Hotspot analysis, so you can work out where there's real trends in the data. Geospatial weighted regression, so you can see what the spatial relationship is between different data sets. Routing and isochron analysis, so if you're in the logistics business, and for some of our use cases later, this is really important. And we've also got industry-specific tools, such as revenue predictors, and loads more. So for people who aren't SQL users or analysts, this might not mean very much, but I just wanted to share this example of analysis with Carto to really illustrate what we're looking at here, because Carto's MO is really big data and the fast analysis of big data. So this bit of code here, which can be executed directly from in your Carto map, so you can execute this and then see the results of it in seconds. What this is doing is taking output areas, which are an administrative geography in the UK, the smallest level of administrative geography, and they have user groups assigned to them. So you'll have things like urbanites and cosmopolitans and things like that. We take those user groups and we convert those into how likely those different groups are to use a delivery service like Deliveroo. So this is basically transforming that data from the output area dataset into a hexagonal grid. So what this is doing is calculating that weighting field, that propensity to use delivery services, and that's for 25,000, 25 would be very impressive, 25,000 output areas across London. Then we join the data table to that, so that's 25,000 data sets joined to, data records, joined to the geometry. And then do an area-based aggregation to 19,000 hexagonal cells. So what that does is basically, like a jigsaw puzzle, sort of cuts where they intersect, work out the proportion of the area that intersects with the cells, and then totals them up. And that is 25,000 cells to 19,000 cells, and does all of that in 11 seconds. So if you're not a GIS user, I can imagine that might not mean much to you, but as someone who used to be a desktop GIS user, that would have taken me an hour to run on my desktop, and it's just, the difference is staggering. So moving on to quick service delivery and spatial data science. So there's sort of three main groups that I'm going to talk through today of what the main spatial problems are that quick service delivery businesses have. So there's customer problems, there's logistics problems, and then there's restaurant and store problems. So here's some examples of some customer problems. How does customer experience vary in different locations, and why is this? So one really key performance indicator of delivery businesses like Deliveroo is what is the difference between if I think I'm going to get my fish and chips in half an hour, but it arrives in 40 minutes, that's okay. If it arrives in an hour, that's a problem. If it arrives in 10 minutes, that's a problem, because I might not be back from the pub by then. So that's a really key performance indicator, is what is the error and the difference between the estimated delivery time and the actual delivery time. And this visualization here shows that, again, aggregated to hexagons. So you can see the tall pink areas are areas, this is based on model data, by the way, not actual data. The tallest pink areas are areas where that error is the highest. And from that, you might be able to start to look into, are there traffic problems in that area? Do I have a shortage of drivers? Are there specifically underperforming restaurants or any infrastructure there that might be causing real problems. So that's just one example. Some other examples are looking at, and this is something we're going to look at in a second in the live demo, Wi-Fi pending, is what is our total addressable market? So what are the total number of people that we think that we can be delivering to within a city or an operational area? And then where is that untapped? So what can we be doing in certain areas to get more customers involved, basically? How do customer preferences differ in different locations? And again, this will be part of the live demo, but in certain areas, people might be more likely to be vegans or enjoy fast food or brunch or craft beer. And this is the kind of data that we have available on our data observatory, all accessed through things like social media streams. So this is all completely within the grasp of people doing this sort of analysis. And then finally, and I love this one because this is something that always really appeals to me, is how can we create hyper-local marketing campaigns that show our understanding of local areas to customers? So for example, that's like when you're on the tube and you're going through Wandsworth and it says people's favourite delivery in this area is Thai food, and it just sort of shows a real understanding between the business and customers that can be really, really effective. At least it is on me, but it doesn't take much to get me to order a takeaway. So the second sort of group of problems is logistics. So you probably think that the key sort of problem or question for delivery businesses is what's the optimal route between a customer and their selected restaurant? So what's the fastest route? How can we get this delivery fastest to our customer? But actually there's so much more involved in it. And one of the real additional things that people have to think about is how can we stack orders? So rather than just saying this driver should go to this person because they're nearest and they'll get there quickest, it could be saying actually but we know there's going to be loads of demand over in this area in about half an hour, so we should route our drivers over there and find someone else that will take them a bit longer to get to this customer, and think about those sort of things, or say, actually, this driver, it would be quickest to go that way, but if they go this way and add 10 minutes on, they can pick up another delivery and add that on. And these are the sorts of really complex spatial problems that generate and require so much data to analyze, and that's why you really need solutions like Carto that can really deal with this sort of big data. Thirdly, how many customers can be reached within a 10-minute cycle of each restaurant? So in Carto, we've got these tools called isochrones, which is where you can basically create catchments from different sites. So here, they're pizza restaurants, as you may be able to tell from the very cringe little icons I've added on here. But you can easily work out what is sort of how many people can be accessed within a half-hour cycle from this store. And then maybe you might think, well, actually, we need more cyclists in that area because there's loads of customers within that catchment, or things like that. Where do we have a driver shortage? So being able to match up the number of drivers with the number of expected customers is really important, because if you've got loads of customers in one area but you've got 2 drivers, then there's going to be loads of dissatisfied customers because they're not going to be able to get their food and it's going to go cold, and that makes us all sad. And then if we change the radii of delivery, how will that affect customer experience? So for example, when you really want that fish and chips and then the restaurant is about 100 meters outside your radius, so you can't actually get it, or you have to pay £2 more, it's thinking about those things and about how that can affect customer experience. Checking time. I think we're okay. And then finally, restaurants and stores. So this example here is something that if you've walked past our stand, which is just here, you might have seen flashed up on our screen. It's all about where should we open a ghost kitchen. So if you're not familiar with ghost kitchens, they're where restaurants like, I think Dishoom does it in London actually, where they have loads of restaurants in central London, but they can't serve people living in outer London. So they open these kitchens that don't have a restaurant attached to them, they're just kitchens, and they can deliver from there. So you can start to think about where might be good locations for them. Based on this example, it's looking at they want to be far away from existing restaurants, but they want to have a high customer catchment. And I think this example was saying where people had a really strong interest in Asian food and culture, which is again one of those social media streams that we have on our data observatory. Secondly, where is there a mismatch between customer preferences and restaurant availability? So following on from that example, if customers are really interested in Asian food and culture, but there's no Asian food and culture, Asian restaurants available in their local area, then they might not order from you. So it's about thinking about which restaurant should we be targeting to sort of join our business. And then finally, how do restaurant opening times align with customer demand? So you might have restaurants in an area that are only serving food till 9 o'clock, but actually there's loads of bars and restaurants in the area, people are pouring out of them and they're wanting food at about 11 o'clock midnight, and working out where are those mismatches so you can sort of manage your restaurant catchment better. So I think I have 10 minutes to go. So I hopefully will be able to perform this demo. Please bear with me. So this demo that we're going to run through now is just a really simple look at how can we use location intelligence to work out where London needs more brunch spots. I'm a millennial, so I love brunch. I'd rather go to brunch than buy a house, apparently. So that's what we're going to look at today. So please, Wi-Fi, help me out. Great. So I've preloaded all of the pages that I need, so I won't walk this through like I normally would, just in case. But this is what Carto basically looks like. So everything that you want is here in the browser. There's a few different things you might be interested in. First of all, we have this developer tab. So if you have JavaScript skills and you're interested in creating your own app or solution, then that's perfectly possible with Carto. We have here your connections, so you can connect to all of your different cloud data warehouses or your Postgres data warehouse. You can also upload things like CSVs and shapefiles if that's more your bag. Just imagine I'm clicking on these and going onto really beautiful looking pages because I don't want to break things. Again, our data observatory, so this is where you can subscribe to the 11,000 data sets that we have. Like I said, there's a public facing version of this. If you search for Carto Spatial Data Catalog, you can find everything that you want in there. Data Explorer, so that's where you can see all of your different data sets and maps, which brings us to, in fact, I'll just talk you through the data sets that we're looking at first. So to be able to do this analysis, we need basically two main things. First of all, we need to know where do all the existing brunch spots exist in London. So for this, we're going to be using this data set called Places, which is basically an amazing global resource of points of interest data, which historically has been quite a difficult type of data set to get because organisations like government organisations, Ordnance Survey in the UK, they don't maintain these sort of private company databases. Traditionally, people might have used sources like OpenStreetMap to get this data, but that can be incomplete because it's basically a crowdsourced database. So being able to access data like this to work out where those things are is so helpful. So what we're using is this data set, and then we're filtering this data to where the category is brunch. My favourite category. And then this is a data I've mentioned quite a few times today because I'm just obsessed with it. I think it's amazing. It's a data set called Geosocial Segments from our data partner Spatial AI. And it basically ranks areas in London, the UK, the world, against 72 different social segments, where 100 is they are completely fulfill the characteristics of the segment, to 0, they're nothing like them. So the index that we're going to be using here is breakfast and brunch affinity. And where areas are scoring about 100, they're really into brunch. They're talking about it on social media, on Meetup, on Instagram, all day. Where it's 0, they could not care less. They like their 3 meals a day. So to move on to the demo, I hope this is all, yeah, I can't see the screen, so I'm just hoping that this has been moving on from the title slide. So that's what this looks like. So initially, we'll just look at our brunch affinity data set. So we can see that the redder areas here are where people are much more into brunch. The sort of lighter yellow or orange areas are where they're less into brunch. So if we zoom in, and you should see that as we zoom in, the resolution of this data changes, which makes it really light to load quickly, but then as you zoom in, you'll get much more detail. So let's zoom into, do I know where we are in the world? Yes, I think we're here. So we are around here right now, and we can see that people around here are sort of average into brunch. They quite like it, they talk about it a bit, but actually it's areas more in central London where people are really into brunch. But then you've also got these sort of inner city areas like Balham and Clapham. If people know London, they'll know that you cannot move for people having brunch and avocado toast and flat whites on a Saturday morning. So that's what our brunch affinity data set looks like. 7 minutes, we're fine. So to start to bring some intelligence into this and start to think about where we might need some more restaurants, there's a couple of things we need to do. First of all, we need to think about the total addressable market, which is something that I mentioned earlier. So this is about, because that data set is fine by itself, but actually if I bring it back up here, you can see that areas like Heathrow have a really high affinity for brunch, but not many people live in Heathrow Airport. So what we want to do to get a bit more intelligence from that is to basically multiply that score out of 100 with the population to work out what our total addressable market is. So we can see here that around the outer London, the total addressable market is a bit lower. And we've also got, it sort of drops in inner central London as well. As we know, the population in central London is pretty low, but in the inner cities, particularly those areas I was mentioning, like Balham and Clapham, the addressable market is really high, where there's loads of people living there, and they all love brunch. So the final thing that we need to consider with regards to this is where are our brunch spots. So this is our safe graph data, that's our point of interest data that shows where all of the brunch spots are across London. As you can see, Greggs is dominating, which is fantastic because I love a sausage, bean, cheese melt more than anyone. So the final thing that we want to think about here is where are people most deprived for brunch spots? Where are they furthest from brunch spots? So we can bring in this data set here, which I've created using our analytics toolbox, which works out how many brunch spots do people have within about a 20-minute cycle, which I think off the top of my head is about 5 kilometres. So we can see here that in central London, as you'd probably expect, they've got loads of brunch spots available, so they're absolutely sorted. But there's slightly fewer further out. So if I just go back to our affinity level, what we can do is, you can see I've added some widgets on the side here to help us understand the data better. So what we can do is say we're only interested in looking at areas where the total addressable market is high. Let's just zoom out a bit. But where the number of brunch spots available is low. Let's just hide that so it's a bit easier to see. So the areas that are remaining on the map now are areas where the people are really, really into brunch, and there's loads of them living there. It's a high population, but there's fewer brunch spots than in other areas. So these might be the areas where a company like Deliveroo might want to go out into the restaurant community and try and find brunch spots and get them to work with Deliveroo. So that sort of, like we talked about earlier, that alignment of the number of customers and their preferences really aligns with the number and type of restaurants. And the Wi-Fi's just run out, just as I've come to the end of my presentation. So I guess finally, thank you so much for listening. Please do come and say hi. We are literally right here, stand 320. We'll be here all today and all tomorrow. Or feel free to drop me an email, give me a shout on Twitter at Helen Makes Maps. And thank you so much for coming.